So for x to the power of 5 minus 2x to the power of 4 plus 3x to the power of 3 plus 4x equals 5. X is a real number. Equation 1 is a polynomial equation with integer coefficients. According to the rational root theorem, a possible rational solution, x equals p over q, satisfies p is an integer factor of the constant term of the equation minus 5. Q is an integer factor of the leading coefficients of the equation. 1 integer factors of 1 plus minus 1, integer factors of minus 5 plus minus 1 plus minus 5. Thus, possible rational solutions of equation 1 are plus minus 1 plus minus 5. Substitute each of them in equation 1, we find that none of them is a solution, so we can't solve equation 1 using the rational root theorem. Instead, we'll approach the problem using a numerical method called the bisection method. Assume that f of x is continuous on a closed interval a, b, f of a and f of b have different signs. The iterative procedure to find the roots of f of x equals 0. First, we set a1 to be equal to a, b1 to be equal to b, and I to be equal to 0. Next, we set the iteration number I equals I plus 1. Then we find x mid, which is equal to ai plus bi over 2. If f of x mid equals 0, then x mid is the root of f of x equals 0. Here we stop the procedure as a solution has been found. Then we check the convergence criteria. The modulus of f of x mid is less than epsilon tau. The modulus of bi minus ai is less than epsilon abs. If so, take the desired roots as x roots is approximately equal to x mid. Stop the procedure as an approximate solution has been found. Otherwise, go to step 6. If I is greater than n max, stop the procedure as no solution has been found. This might be because the maximum iteration number was set to a number that's not sufficiently large, or the function f of x is not continuous. If f of x mid times f of a is greater than 0, then f of x mid and f of ai must have the same sign. So the root is in the interval x mid and bi. So we set ai plus 1 to be equal to x mid, bi plus 1 to be equal to bi. Go to step 2. If f of x mid times f of ai is less than 0, then f of x mid and f of ai must have different signs. So the root is in the interval ai and x mid. So we set ai plus 1 to be equal to ai and bi plus 1 to be equal to x mid. Go to step 2. We let f of x equal x to the power of 5 minus 2x to the power of 4 plus 3x cubed plus 4x minus 5. F of 0 equals minus 5. F of 1 equals 1. We set n max to be equal to 100, etal to be equal to 0.001, epsilon abs to be equal to 0.005. We list the following in columns: iterations, ai, bi, x mid, f of ai, f of bi, f of x mid, bi minus ai. When I equals 1, ai equals 0, bi equals 1, x mid equals 0.5, f of ai equals minus 5, f of bi equals 1, f of x mid equals minus 2.719, bi minus ai equals 1. The modulus of f of x mid is much greater than epsilon tau. The modulus of bi minus ai is much greater than epsilon abs. We can see that f of ai and f of x mid have the same sign, so the roots must be in the interval x mid and bi. So when I equals 2, we set ai to be equal to 0.5. We set bi to be equal to 1. X mid equals 0.75. F of ai equals minus 2.719. F of bi equals 1. F of x mid equals minus 1.130. bi minus ai equals 0.5. The modulus of f of x mid is much greater than epsilon tau. The modulus of bi minus ai is much greater than epsilon abs. We can see that f of ai and f of x mid have the same sign, which means the roots must be in the interval x mid and bi. So when I equals 3, we set ai to be equal to 0.75. We set bi to be equal to 1, x mid equals 0.875, f of ai equals minus 1.130, f of bi equals 1, f of x mid equals minus 0.150, bi minus ai equals 0.25. The modulus of f of x mid is much greater than epsilon tau. The modulus of bi minus ai is much greater than epsilon abs. We can see that f of ai and f of x mid have the same sign, so the roots must be in the interval x mid and bi. So when I equals 4, we set ai to be equal to 0.875. We set bi to be equal to 1, x mid equals 0.938, f of ai equals minus 0.150, f of bi equals 1, f of x mid equals 0.401, bi minus ai equals 0.125. We can see that f of ai and f of x mid have different signs, so the roots must be in the interval ai x mid. So when I equals 5, we set ai to be equal to 0.875, bi to be equal to 0.938, x mid equals 0.906, f of ai equals minus 0.150, f of bi equals 0.401, f of x mid equals 0.120, bi minus ai equals 0.063. The modulus of f of x mid is much greater than epsilon tau. The modulus of bi minus ai is much greater than epsilon abs. We can see that f of ai and f of x mid have different signs, so the roots must be in the interval ai x mid. So when I equals 6, we set ai to be equal to 0.875, bi to be equal to 0.906, x mid equals 0.891, f of ai equals minus 0.150, f of bi equals 0.120, f of x mid equals minus 0.016, bi minus ai equals 0.031. The modulus of f of x mid is much greater than epsilon tau. The modulus of bi minus ai is much greater than epsilon abs. We can see that f of ai and f of x mid have the same signs, so the roots must be in the interval x mid bi. So 1i equals 7, we set ai to be equal to 0.891, bi to be equal to 0.906, x mid equals 0.898, f of ai equals minus 0.016, f of bi equals 0.120, f of x mid equals 0.052, bi minus ai equals 0.016. The modulus of f of x mid is much greater than epsilon tau. The modulus of bi minus ai is much greater than epsilon abs. We can see that f of ai and f of x mid have different signs, so the roots must be in the interval ai x mid. So 1i equals 8, we set ai to be equal to 0.891, bi to be equal to 0.898, x mid equals 0.895, f of ai equals minus 0.016, f of bi equals 0.052, f of x mid equals 0.018, bi minus ai equals 0.008. The modulus of f of x mid is greater than epsilon tau. The modulus of bi minus ai is greater than epsilon abs. We can see that f of ai and f of x mid have different signs, so the roots must be in the interval ai x mid. So 1i equals 9, we set ai to be equal to 0.891, bi to be equal to 0.895, x mid equals 0.893, f of ai equals 0.016, f of bi equals 0.018, f of x mid equals 0.007, bi minus ai equals 0.004. So the modulus of f of x mid is less than epsilon tau. The modulus of bi minus ai is less than epsilon abs. So it's converged. X roots is approximately equal to x mid, which is equal to 0.893